Hello, everyone. Good to see you all. Thanks for joining the session. Imagine that today we all use some kind of search application or chat application pretty much every day in our life. So organizations are trying to build those over the last few years using different technologies. But in the last couple of years, things have changed drastically with the Gen AI, which is forcing organizations to think differently. So in today's session, we'll be discussing about how do you build next generation search and conversational AI with Amazon OpenSearch service. My name is Shubhankar Sumar, Senior Solution Architect with AWS. I'm an AI ML specialist. With me, I'll be joined by two specialists, Varap Patel, who is an OpenSearch specialist, and Jonathan Reid, from engineering manager from Sage, who will be talking about how Sage has implemented conversational AI using OpenSearch service. In the next 45 minutes, we'll be taking you through how Amazon OpenSearch can change your search analytics platform with a practical insight into vector search with conversational AI. So before we get further, let's talk about the basics. What is search? Search is essentially a user comes with a view to get some information from a system for their query. The query could be a simple text, or a searching for a text, searching for video, audio, or image, or a combination of everything. So we call it multimodal search. So the query is sent back to the backend search engine. Search engine gives you back the ranked result, which meets the information goal required by the user. But there's a lot going on behind, and over a period of time, it has become sophisticated, much more sophisticated. So if you see the evolution of search, you all started with the keyword search, like where you match the keyword and then give the result back to the user. But today, we are in an AI agent power search, where the system remembers the context, and it uses the agents to go and interact with the backend systems with the help from LLM and give you the response back. Now, all of these different types of search is possible through Amazon OpenSearch service. Now, before you go further deep into what is search, so let's take a step back and understand the little background of the Amazon OpenSearch open source project. It started in 2021 with Apache Foundation project, and since then, it has gained popularity, and number of our partners like Avon, Oracle, Intel, SAP are contributing actively for its improvement. And Amazon has actually donated the code to the Linux Foundation. So today, Amazon OpenSearch is available with all major cloud providers. Now, the OpenSearch OpenSearch open source project is quite flexible platform. It lets the developer to build the search project very simple and straightforward way. Now, so how it is different from the open source project, the Amazon OpenSearch? So it is fundamentally giving you the opportunity to deploy open source project, open source software into your AWS account with the capability to do search application within the scalable and secure platform. It has two flavors. One is the Amazon OpenSearch service, which is effectively you have the cluster, you define the cluster based on your use case, and then you manage the cluster within the environment. And it's natively integrated with the Amazon SageMaker, Bedrock, and third-party model providers like Cohere and OpenAI. On the other hand, you have OpenSearch serverless. As the name suggests, is serverless. It automatically scales up and down based on the requirement of your based on the load in the system. So depending on the use cases you have, you need to choose which model you want to go with. Serverless typically become cost-effective depending on which model you're going to, which kind of use cases you are using. And it is, the serverless model is also the default vector search for Bedrock knowledge base. So OpenSearch is typically used for three fundamental use cases. One is the core capability, which is a search. It should provide the search capability, which we are all aware of. Second is analytics. It gives you the capability to build your real-time analytics platform with the application and security monitoring capability, observability, etc. And the third one is vector capability for GenAI application. In today's session, we'll be pretty much covering this part of the use cases. It gives you a vector database where you can manage billions of vectors. It is well integrated with the Bedrock knowledge base as a default vector database as well. Now, OpenSearch supports multiple search types. So I'll not go over each one of those, but very high level, sparse retrieval is effectively a lexical or keyword search where it matches the keyword array based on the statistical occurrences of the particular word within your query. It gives you the response. It does not necessarily remember the context where it is being asked. For a dense retrieval, it is actually vector search, which gives you the semantic search capability on top of the different model, purpose in model like for text model, image model, or a video model, or a combination of those multimodal capabilities. And the hybrids are, of course, a combination of both. Now, in today's session, again, we'll be covering mostly the conversational search bit, where the OpenSearch provides the capability to integrate and leverage LLM and RAG to give you very sophisticated, accurate conversational capability in a natural language. It also takes the advantage of the foundational B25 base KNN for vector search with the help of the capability of LLM as well. Now, we talked about all different kinds of search. Now, let's take a quick example of how contextual or semantic search is very different from the lexical or keyword search. So let's imagine you have an e-commerce platform where they're selling thousands of items. And as an user, you want to search tennis clothes. So if you see on the left-hand side, it is a result of the semantic search, which is aware of the customer need and gives you a relevant result. On the other side is the lexical search output is not much relevant what actually the user is looking at. So in today's world, you would probably look at more context-aware semantic search capability within your platform. Now, how do you do that within Amazon OpenSearch using the vector search capability? So my colleague, Bharat Patel, will now come and take you through that journey. Welcome, Bharat.
Thanks, Subankar. Hey, everyone. My name is Bharat Patel, and I'm a specialist solutions architect working in Amazon OpenSearch service. We saw how semantic search improves the quality of the search, but how can we implement that? We humans understand the natural language and relationship of words in a sentence, but machines don't, right? It only understands numbers. And to do that, we use the embedding models like word2vec or fast text, or use a BERT or GPT, which takes this natural language text and convert it into the array of numbers. That's called the vectors. If you look at the first three sentences, it talks about the city of the world, and it is the similar characteristic. And because of that, the generated numbers are also closer to each other. And it's not only about the text. You can generate the vectors from image, audio, video, and perform the context-aware semantic search on this multimodality of the content. But when you are working with multiple or the large amount of the data, let's say billions of documents, each document having thousands of dimensions, we need something purpose-built created for the vectors. OpenSearch is a powerful vector engine which can efficiently store, search, and retrieve the vectors. It comes with a wide range of features to run your workload. So we support a multiple method which takes these numbers and generate the internal graph representation from the vectors. We support HNSW and the IVF methods. To implement these methods, we support the leading engines like NMSlib, FISE, and the native Lucene libraries. OpenSearch supports multiple quantization methods which you can use to reduce the dimensionality and the cost without sacrificing on the quality of the search. And you can run the vector workload in both provision as well as serverless offering. OpenSearch offers out-of-the-box connection blueprints, which you can use to generate vectors automatically during search time and ingest time by talking to the model which is hosted on the external model hosting provider. OpenSearch is not only a vector database, it is also a powerful text search engine. So you can store your text data and vector data and perform lexical search and vector search. You can also combine this search using the hybrid query inside OpenSearch. Efficient filtering helps you massively pre-filter billions of documents using the metadata of the document and narrow down the potential search and only perform the nearest neighbor search, which is resource intensive, to improve the search performance. Let's see how OpenSearch fits into your vector workload. Let's say you are building the enterprise search application with image, audio, video documents. We take these documents and send it to the embedding models, which generates dense or sparse vectors. And we take these numbers and store it into OpenSearch using methods and the algorithms we talked. It takes this internal graph representation, and during search time, we take the query text, which uses the same embedding model, and perform the nearest neighbor search in the vector graph. And you can do so with the use of the high-level APIs of OpenSearch. If you look at this workflow, there is a bit of a task you have to do to connect to the remote models hosted in external model hosting provider. We simplify this with OpenSearch Neural plugin. It provides readily available connection blueprint, which you can use to connect your models running on Bedrock, SageMaker, OpenAI, or even self-managed models. With that, you can directly send your raw data to OpenSearch, which talks to the remote hosting models on behalf of you, generate the vectors, and store that into OpenSearch. During search time, we take this natural language query, talk to the models hosted remotely, generate the vectors, and perform the nearest neighbor search to get back the results. All right, so we talked about the VectorDB capabilities of OpenSearch and how easy it is to integrate with the remote models. Now let's talk about the different search type available in OpenSearch. First, vector search. We already saw how semantic search understands the context and intent of the query to improve the quality of the search. Let's see how we can do this. Let's say we are building an e-commerce application to find the right product, where user can simply find the products by entering the natural language text. To do that, we take the product description and use an ingest pipeline that talks to the dense embedding models. Here I am using the Titan text embedding model. This model generates dense vectors, store that into OpenSearch. During search time, you can simply ask styling kicks if you want to find the sneakers, because it generates now the context of the query, and perform the nearest neighbor search to find the best match for your query. This way, you can remove the need to perform the faceted search or categorical filtering you do traditionally. Multimodal search comprehends an image the same way LLM understands the text, so that you can build the chatbot applications using that. To implement that, along with the product description, we also pass product image to the ingest pipeline. The ingest pipeline now talks to multimodal embedding models. This is the model which works with the multimodality of the data and generates the dense vector out of it, and store this vector in a single vector space inside OpenSearch. Now during the search time, you can either pass the query text or query image, or both. This way, you can find the similar looking products and improve the search experience. All right, so as I mentioned earlier, OpenSearch is not only a vector database. It is also a powerful text search engine where you can co-locate your text data and vector data. Hybrid search allows you to combine these multiple search types into single query. To do that, you run multiple subqueries of different types inside a single hybrid query. Those queries run separately inside OpenSearch. The way OpenSearch manages the search is with the query phase and fetch phase. But with the hybrid search, we intercept the results received from the query phase and normalize the score, because the scale of the score is different in both the search types. So we normalize the score and get you the sorted results based on the score. This is good when you do not want to solely rely on the text search or vector search, but you also want to get the flavor of both the search types in a single query. OpenSearch allows you to define the weight of each of the query. So if you want to align more towards a text search or vector search, you can do so. All right, so far we talked about semantic search, multimodal search, and hybrid search, which works with the dense vectors. Neural sparse search alternatively works with sparse vectors for more efficient searches, because it works with, on the text matching algorithm BM25. To implement that, we take the product description, pass it to the sparse encoding model. This is a model which generates the sparse vectors. And if you look at the sparse vectors, it is in the form of keyword and weight. During search time, we take these query text and expand it with the similar keywords and weight, and perform a dot product operation inside OpenSearch. This works much efficiently because it uses much less compute and the storage resources, because it's doing just dot products on the weight of the keywords. But at the same time, it also maintains the semantics of the query. And finally, RAG. Anyone here not familiar with RAG? Yeah, I think most of you might be familiar with the RAG, right? It's a popular technique to build GenAI application where you allow LLM to access the external knowledge base to improve the search accuracy and relevance. Let's say you are building a chatbot application for employees to find the right policy from thousands of policies. So this is a basic generative AI application which is backed by pre-trained LLM model. When employee asks about a leave policy, this model may make up the answer, because the pre-trained models comes with certain limitations. It is trained on the publicly available data set, but when you ask specific about the domain knowledge, it may hallucinate. These models are stuck in time. So if your knowledge base keeps updating, you have to retrain the model. But that comes at a cost. And the models has a very low interpretability, because all the knowledge stored in the LLM is in the form of parameters. So if you want to verify the source of the answer, you cannot do so. And that may be the problem for certain businesses, right? Considering all these limitations, it makes sense to store your knowledge base somewhere outside of LLM, where you can easily update, manage, and delete these knowledge documents without touching LLM. With this approach, let's say we have taken all thousands of company policy, generated vectors, and stored it inside OpenSearch. Now, employee asks about the leave policy. We generate the vectors and perform a semantic search against the policy knowledge base inside OpenSearch. OpenSearch returns top matching documents And we send this to LLM to augment a prompt. So we are now asking LLM, only rely on the data which is received from OpenSearch. Do not make up your own answer. This approach prevents the hallucination. But OpenSearch makes it even better with conversational experience. Along with the knowledge base now, we are also storing the question and answer history of the user against his profile. So when employee asks a question next time, along with the top matching documents, we also pass the conversational history to the LLM. So now LLM know better about the user's profile and his conversation history. So answer can be improved. And we also allow users to ask a follow-up question to refine the answer without providing full context every time. All right, so we talked about different search types. Now let's see them in action. This is a sample e-commerce application to find a right product from the product catalog. We will use different search types we talked about and see how it impacts the quality of the search. We'll first start with the keyword search. I'm trying to find trendy footwear for women. Keyword search matches the keyword against the product's description without understanding the context of the query. And if you look at the search result, we see the jackets, a coat, and the glasses in the footwear search result. That is not relevant, right? To improve that, now we use vector search or semantic search. With this, now we generate this query text into dense vectors to better understand the overall context what user is trying to ask, even if there is no matching keyword. And if you look at the search results, I get much better search result, even if there is no matching keywords in the description. To even improve the performance or user experience, now we use a multimodal search. With this, along with the query text, I also pass product image. So I change now search type to a multimodal search and pass the product image for which I want to find the similar looking product. And if we look at the search results now, this is even better because sometimes we cannot describe the product clearly in the keywords, right? So this is a great way to provide this multimodality of content. And finally, hybrid search, where you can combine these multiple search types in a single query. I am combining keyword search and vector search here. I'll go with the default weight, which is 50-50 here. That means it normalizes score on this 50 equal weight. If we look at the search result, I see the jacket in the search result, but other results are good. And that may be coming from the keywords. To improve that, now I change the weight of the vector search to 80% and reduce the weight of a keyword search to 20%. With that, if we redo the search, I see most of the products are matching what I am looking for. So you have this knob to change the behavior of your search query. All right, so we talked about different search provided with Amazon OpenSearch for different use cases. And you have the flexibility to choose the search type which fits your use case and build amazing search systems. With that, I would like to invite Jonathan to walk us through how Sage built a conversational search with Amazon OpenSearch.
Hello, everyone, and thank you, Bhairav. So I'm going to talk us through how Sage have implemented the solutions that Bhairav has gone into from a technical point of view. To give you a bit of background, Sage is a market leader for payroll, accounting, and payment systems worldwide. We offer hundreds of products to the market that we're able to sell, and my teams are responsible for integrating with those products to speed up delivery and offer services that we can integrate with those products. So the use case that we're going to go into is with a product called Intact. Intact is a product that streamlines financial management for growing orgs that no longer require the need for off-the-shelf products. So Intact's challenge was around a legacy chatbot system that they had. Some of the issues with that chatbot system was it contained outdated technology. They were unable to update it as fast as they would like. They were unable to respond to their customers' needs as quickly as they would like. There were too many questions the customers were asking, questions like, how do I do this, how do I do that? And that would often result in the right type of material being hard to find. So think of your Google-like searches, you input a term, and you then get a list of results, and you might have to scroll through 10, 20 of those results before you find the answer that you're interested in. Intact are also scaling a lot. They're going more global, ever-growing portfolio of products. So with that becomes more need for them to be able to handle the requirements of what their customers are setting. So what we looked at in my team is creating a solution based on the technologies that Bhairav went through. We needed to create a single scope knowledge base. So this is tying into the LLMs that Bhairav mentioned around being able to scope the results just to that single piece of data that Intact are interested in. In this example, their help documentation. They needed a central service for their users to be able to experience, and their users in this case, not just customers, but also the content managers that work for Intact. Previously, they had many systems they had to navigate through and to ingest the documents, the data, and also look at analytics and the way the queries are performing. They also had a need to filter these queries, so they needed to filter it by domain, region, and product. One of the things we discovered early on was the need for us to build a self-service portal to be able to enable them to do this. So we call this the content management system. And with this, what we were able to do is build a portal that essentially allows content managers to point where they want their documents to be ingested. They're able to create automated testing off the back of that to ensure that the questions customers ask are going to retrieve the relevant answers as well. They wanted to be able to respond to needs of the customers when released documents need to be updated or published for the first time, and also when there are issues with the help documentation that needs fixing. Those need to get into customers' hands much quicker. So why did we choose RAG? So we chose RAG because we have the need for a fast ingestion for the use case that I've just mentioned. Those content updates need to be happening quickly. We also have strict legal requirements around this, and that's hensing the need to scope it to the data that Intact are interested in. There was a recent case where a chatbot for an airline had to refund hundreds of customers because they got the T's and C's incorrect out there. That we can't afford for that to happen. We want to make sure that the answers are relevant and accurate for the customers. The ability to scale more is crucial as well. OpenSearch gives us this massively, and we've got experience of doing this from previous projects and our relationships with AWS. Now you might look at that and think, well, why not fine-tune an LLM model to be able to really understand and interact with the data that Intact are interested in? In our experience within my teams, we've found that takes a lot of engineering effort compared to what Amazon Bedrock gives us out of the box. We're able to spin up a POC very quickly to be able to do that, and then use the models that are available within that. So a little bit about why Amazon OpenSearch. Like I've said, we've already got a very strong relationship with AWS, and we lent into that to be able to spin that POC up very quickly. It's proven to be able to scale to handle the business needs in terms of when the portfolio of help documentation grows for Intact, and also the scaling of user requests coming into the service. So the more questions being asked throughout more times of the day at a global scale. It offers multi-region support. Intact, again, are global. We would need to host the data and store it in the regions that it's relevant in so it doesn't cross borders. Very cloud native, obviously. It helps us to be able to scale and lean into those actions. And then the fast ingestion as well. We found that it's very quick to take the data that we're interested in, the documents, and ingest that quickly to be able to allow users to retrieve it quickly. The big thing though is it gives us that hybrid search. So we can do text and we can do vector searches. The use cases aren't always rigid to say that we just need to run RAG, run vector searches. We'd like to offer both. So when we're implementing with the hundreds of products that Sage offer, we're able to offer the need to meet multiple use cases by having those multiple different types of searches. I'm going to go through 3 layers of diagrams now. The first one is a business layer diagram, and we've got a top and a bottom section to that. The first top section is all about how a user can interact with the Intacct product, and then how it calls out to the semantic search API. And the bottom section is just talking about how that content hub is the place for the content managers to specify where their documents need to be crawled and need to be ingested and stored from. I'm going to go into a bit more of a high level diagram now. So at the top here, we've got the client integrations. What was very important for us to do from the start is we're not a UI team. We haven't got specialist skills to be able to build UIs, but Intacct do have them, and the other products around Sage do have those specialist skills. So they need to own how this is displayed to the user, and we can handle the logic behind how the answers are generated and then passed back to the product for them to be able to display how they've seen. That helps us scale. That helps us get the solutions out to the products faster. The next box of the semantic search service is core, absolutely core to the service. We've got an API there using Fast API. That queries the AWS Bedrock for retrieval. It interacts with an LLM. We've chosen the model HiQ 3.5 to be able to interact with it. I'll get to why we've chosen that shortly, and also how we can test and quickly validate other models. Within that, you can see we've got some caching there. So one of the obvious things that became apparent from the start is that users are going to ask the same questions. LLM calls can be expensive. They can not be responsive. So there's a little bit of a delay there. So when we're seeing common questions being asked, the same questions, we can cache those and serve those back to the user fast, making that experience a lot better for the user. We've also got DynamoDB there. So here we store all the questions and answers that we receive, as well as some other metrics. And we pass them out to a semantic search analytics feedback service. So within my area, we also have a data platform team that handles all of our data that's coming around Sage. They have a Snowflake instance, and they're able to ingest the data that we publish to them through DynamoDB. And then from here, Intacct can build very powerful Power BI dashboards to really get insights into how this is performing, how this is working for their customers. And that enables product managers to be able to make really informed decisions around how a customer is using it, how can they improve the usage of it, and then also it feeds into how can they improve their product features and offerings within the Intacct product. The final section here is about the quality evaluation framework. This is the benefit of hindsight for us, because midway through the project, we realized that quality and accuracy of answers is extremely important. So we decided to build this framework using LangFuse. And for those of you that don't know, LangFuse is an open source LLM as a judge. It gives you lots of metrics, analytics, evaluations. And then what we're able to do is put the answers and questions through, taking gold label answers that Intacct generated for us to say, hey, these top 10 questions are the most important to us. We need to ensure that these are highly accurate. So with the evaluation framework, we can run those questions through that, generate the answers before it's even in customers' hands in production, and understand what the quality is doing for Intacct, but not just for Intacct, for us as a service. We can start to understand, as we're developing features, is our quality going up? Is our quality going down? Obviously going down is bad. We need to look at the feature we've developed, roll it back, and start to go back to the drawing board for that. So that really enables us to measure that quality and that accuracy for our customers and ourselves. On the right-hand side there, we've got the Content Hub, which I'm going to move on to now. So the left there, number one, is the web client that we've built. This is where the content managers of Intacct will log in, see their knowledge bases that exist in AWS Bedrock. They're able to configure new runs of the data on the right-hand side there. Intacct's use case was a website where their product help documentation is hosted. So we built a crawler to be able to scrape that website, ingest all of the information into S3, and we can sync that on a manual or an automatic schedule. And what this does is it gives us the ability to be able to respond to updates to the help content as and when Intacct need us to. From there, after we've stored the raw contents of the data, we put it through a publisher. So we have a publish to Bedrock instance there. We've got lambdas that check for differences between what we host currently. Obviously, if this is the first time you've run it, you're going to have a massive list of information that we need to store, vectorize, and make available to Bedrock. But we can also respond to when you update that content, it might only include one new file or one edit of a file. So that means the ingestion's faster. We're not constantly deleting and recreating the ingestions. That processes the documents and puts them into chunks. So if we've got a document that has 10 paragraphs, we might create 10 chunks of those. So when a user is asking a question, we're able to look up the right chunk to get the relevant answer based on that query. So what does all of this mean for Intacct, and what results have they got? So the success for us as a team and also Intacct is we have created that unified user experience. They have got that single place with the Content Hub to be able to go to ingest their documents, understand how the service is being used in product, retrieve analytics and metrics, and help them make decisions around how they can improve their product. They have reported a 40% reduction in support tickets. So this is someone picking up the phone and not being able to find the help from the help documentation that exists on the website. What that 40% gives them back is time for the content managers to look at what their content is doing for their customers. They can improve it, they can make informed decisions for their own backlog and help them scale at the pace that the business needs them to. We are tracking an 80% accuracy in our answers. So obviously tying into Bara's point about hallucinations and everything that's possible with AI and LLMs, we're very pleased with that score as our initial implementation. We will be making improvements to get higher accuracy, but what that means is we're able to track that now with the quality evaluation framework that I talked about, and then see what our work, our features, our enhancements are doing to that accuracy over time. We have created that internal self-serve for rapid onboarding as well. So what's going to happen now is as we go around the Sage business, we're able to offer this to other products. We've created a playground area for them to be able to upload their data, start to interact with their data through chatting with it and understand the experience their customers will get before they even need to integrate it with their product. So they can start to learn about this service offers X, Y, and Z, and it will give you this benefit before they need to dedicate engineering time to it. So with our learnings, a little bit of the things that we're going to do for the future is Amazon Bedrock was great as a POC to ingest directly into there. We believe we can ingest faster by going directly to OpenSearch. So we're exploring what that means now to be able to increase that time from Intacct uploading their documents to being available to the customer. We can make that faster. We're enabling more features in the Content Hub to make it a really self-serve product. We're working with the content managers to understand how they would like to use this system and then what benefits we can offer with further features. Improving the quality evaluation framework. This is basically to improve and track that accuracy so we can execute on the correct features in our roadmap and make sure that the work we're doing is going to be relevant and accurate for our customers. And the caching and retrieval improvements, obviously, everybody's experience with AI is it's not as responsive as most things that we're used to in today's world. So we're going to make improvements around how can we speed those requests up, how can we get them into our customers' hands faster. And with that, I'm going to pass back to Shubhankar to close off. Thank you.
Thank you. Thank you, Jonathan. That was quite a lot of insight how Sage has implemented their conversational AI with Amazon OpenSearch. Now it's time for you to go and try it out and try this scalable solution from AWS. Now, if you're planning to do hands-on, so there are in the third floor of the auditorium, you can go and do the hands-on today. It's after 1 o'clock. Look at your app, look at the Summit app and see the exact timing and which room it is. There are a number of programs within AWS which is running, which can help you to start up the whole journey. just talk to your AWS contact to get more information on that. So this is what you can start, put your hands in and try it out how it works. There are a number of vector search guides. You can look for those and as relevant and go further inside and to see how it works, from OpenSearch Vector DB to introduction to vector search, AI search, and of course there are skill builder course where hundreds of skills, hundreds of programs are there where you can get trained free of cost on number of services, not necessarily Amazon OpenSearch, but many other services from AWS. With that, thank you very much. Please do give your feedback. And once again, thank you for attending the session. Have a good day.